So let's look at area and volume part 3, where we look at the cone, and we can see the volume of a cone is a third pi r squared h. The curved surface area is pi by r by l, where l is known as the slant height, and the slant height L is equal to the square root of h squared plus r squared. That's considering that this is a right-angled triangle and we're using Pythagoras' theorem. Okay, and the total surface area of a cone is pi r L, which is this curved surface area, plus the area of the circle underneath, which is pi r squared. Okay, and the types of questions you're asked with the cone: you're given H and R, and you're asked to find the volume of the curved surface area. Sometimes they'll add two shapes together like a cone and a cylinder and ask you some questions around that using the formulas. Or you're given the volume, the actual value of the volume for the cone, and you have to find some other unknown. And like the sphere and the cylinder, sometimes we have to find the rise h if a cone is dropped into water in a cylinder. So like we did with the sphere, or the ball dropped into a cylinder, we find the volume of the cone, we let that volume equal to the volume of the cylinder it's being dropped into, and we find h. So I'm not going to do any cone problems in this video. You can look in the text and test book for examples of the different cone type questions, but they're along those lines. There are more difficult problems we meet in the area and volume chapter, and there's two types. There's the type which I suppose associates itself with water flowing through pipes, and you're asked for to find how long it will take to fill a pipe if you're given the rate of which the volume is filling. So there's a basic formula that we can always use. The time taken to fill a pipe is equal to the fill pipe volume divided by the rate pipe volume, and I'll explain this with use of an example. Okay, so here's an example here. Water flows through a pipe of diameter 3 at a rate of 14 centimetres per second. How long will it take to fill a pipe of diameter 14 and height 45 centimetres? Well, the time taken is equal to the fill pipe volume divided by the rate pipe volume. So what is the fill pipe volume? Well, the volume of the pipe or cylinder is pi r squared h, and we see here find how long it would take to fill a pipe of diameter. So this is my fill pipe that I'm referring to. These are the dimensions of it here, of the fill pipe. So we've pi by half of 14 is 7 squared times the height 45. So the fill pipe volume is pi by 2205 centimetres cubed. And then we're looking to find the rate pipe volume. Well, that's pi r squared h again, but in this case it's the pipe in which we're given the rate for. It's the dimensions associated with the rate of pipe. Okay, so that's pi r squared h, so that's half of 3, the diameter, gives us r squared by 14, and that's 31.5 pi centimetres cubed each second. So therefore the time taken is our fill pipe volume divided by our rate pipe volume, and the time is 70 seconds. And the second type of more difficult problem we'll meet we met in this chapter is to do with ratios. So we have something like a cylinder and cone have radii of equal lengths. If the height of the cone is twice the height of the cylinder, find the ratio volume of cylinder to volume of cone. So the formula for the volume of cylinder is normally pi r squared h, but the height of the cylinder is half the height of the cone, or the cone is twice the height of the cylinder, so that becomes h over 2, and the volume of a cone is a third pi r squared h. Okay, so now we've taken into account that the height of the cone is twice the height of the cylinder by dividing the height of the cylinder by 2. So these would, pi r squared and pi r squared would cancel, and we end up with h over 2 to the ratio of h over 3, okay, and that would tell us that if we cross multiply 3h to 2h, okay, and if the h's cancel, the ratio of the volume of the cylinder to the volume of the cone is 3 is to 2. And now we'll meet with the trapezoidal rule, okay, and the trapezoidal rule states that for any given shape, like this, we can find the area of that shape if we divide it into equal strips, okay, of width h, and we have these heights here. We can use the information of the width h and the different heights here and put them into a formula which will allow us to calculate the area of that shape. And the formula tells us that the area is equal to this width dimension, remember these are all the same, okay, divided by 2, all multiplied by the first height plus the last height plus 2 times the sum of all the remaining heights that we haven't accounted for. Okay, and that is the trapezoidal rule, and the trapezoidal rule is born out of the fact that actually what we're trying to do here is we're trying to divide that shape into many trapezoids as close to the line as possible. Okay, so if you remember we had A, B and H, so it's like a trapezoid on its side. Okay, so let's look at this example here. Find the area of the shape with height h equal to 10. So that's these widths of strips are all equal to 10. And we have the different heights, 24, 28, 34, 32, 26, 24 and 30. Okay, so we're looking to find the area of everything under the curved line using the trapezoidal rule. So we simply say, using the formula here, we say the area is 10 over 2, all times the first height plus the last height plus 2 times all the other heights in between, all the sum of all those other heights from inside the area. So that all gives us 10 over 2 times 54 plus 2 times 144, so that's 5 times 54 plus 288, 5 times 342 is 1710 meters squared. Here's the second example. Below is a graph of the function f of x equals x squared minus 8x plus 17 in the domain x is greater than or equal to 0 and less than or equal to 4. So the question is, use the trapezoidal rule to estimate the area between the curve and the x-axis. Okay, and the x-axis, use a width of 1 unit. So there's our 1 units here: 1 to 2, 0 to 1, 1 to 2, 2 to 3, 2 to 4. So it's all our h in our formula is equal to 1, and we have the heights here: 17, 10, 5, 2 and 1. So we plug those all into the formula, h over 2, first height, the last height, 2 times the sum of the heights in between, and we get our answer equal to, so our answer is equal to, we can't see it here, but it's equal to 26. And the second part says if we're getting an area of 26 meter cubed, or whatever it is, whatever the units are, okay? And the second part says if the exact area is really 25 1/3, because the trapezoidal rule is like an approximation, find the percentage error. So to do that, we need to say, okay, well, what's the difference between what we got and what it actually is? And the difference is 26 minus the actual value, and that's 2/3. And so the percentage error is equal to that error over the actual value. So we've 2/3 divided by 25 1/3, all times 100, and that's equal to 2.63%. Here's the third example, and it's to do with adding offsets. These are known as ordinates or offsets. Okay, and we can actually add them if we have a shape that goes above and below our baseline. Okay, so a surveyor estimates the area of a plot of land, this denoted here, to be 612 square meters. find x, find our widths of strips. So we just put that into the formula, a equals x over 2. Now, that's the first height and that's the last height, and you'll notice that they're both 0. Okay, plus 2 times the sum of these, which is 13, some of those is 12, and some of those is 9. And that all boils down to 1224 is equal to 68x. X must be equal to 18 meters. And here's the final example and the final type for the trapezoidal rule, where you're given a shape, you're told to divide the edge AB into 5 equal parts and to find the area. So for something like this, if you met with this in a problem, then you'd have to get out your ruler, measure AB and divide it into 5 equal parts, okay, and measure that, and you'd know what your H value is equal to. And then from those you extend up to the curve with your ruler, and you measure these heights here. Okay, and you'll have a value for your first height. If I call that A, your second, C, D, E, and here F equals 0. The last height is 0, and you simply plug that into the formula here, and you should be able to find an area. So remember, for this one, you're actually using your ruler to divide and measure to find your different values that you plug into your formula.